Hey, what's up, guys? So, what have you guys been up to? Matrices? Yeah, that's cool. So, let's get into the situation. So, here, there is a situation where Alung give a code in the form of matrices, and in the form of matrices, which we can decrypt into a message, which means meet me at noon. But the problem is we don't know where. So Alun gave us another matrices which we don't know what the meaning is. So our task is there are given another three matrices K1, K2 and K3, which each of these matrices will be solved by different method, which K1 we will solve by using adjoint method, K2 will be solved by using ERO method, and K3 we will solve using inverse method. So let's get into the first method, which is K1.
Okay, this is K1 matrices, which is we use adjoint method. This is 4 times 4 matrix. So first of all, we need to find the cofactor, which is the formula -1 power of I plus j times mij. So if we want to find the cofactor, we need to choose the C11, which is row 1 and column 1. So for this, we get 1, and for this, we look at the K1. So for row 1 and column 1, we need to close the row 1 and close the column 1. So we can find the 3 times 3. So here, we put it here. So to solve inside the matrices, we need to use the formula of A times D minus B times C. So here, 3 times 1 times 3, we get positive 9. 5 times 1 times 4, positive 20. 1 times 3 times 3, positive 9. And we use this same formula but in a opposite direction. So 1 times 1 times 4. So we need to use negative because of its opposite direction. So we get negative 4. 5 times 1 times 4, negative 45. 1 times 3 times 3, negative 9. So we solve here and we get negative 20. So we need to find the other cofactor for all the number here. So the final answer is here. So this is the final answer for all the number of the cofactor. Next, we need to find the determinant, which we need to use this formula, A11 times C11 and so on until A14 C14. So we just put the number here, use the matrices that we have found just now. So we get the determinant 7. Next, this is the final answer for inverse of K1, which is using adjoint method. So the formula to find the inverse is 1 over determinant times transpose of our K1 just now. So 1 over 7, this is our determinant, and this is the transpose of our inverse. So next, the matrices given, which is P, that we need to find that the matrices can find the code. So we need to times the P with our inverse, and this is the final answer. So there's no messages that we can find.
So hello guys, so now I will explaining to you guys on how we are going to find the K2 matrices inverse matrix using the ERO method. So the first step is we need to change the row 2 with the row 1 from here to be here. So now we already have 1 in here and we need to make all this turn into 0. So how we are going to make it turn into 0 is we must row 3 plus 2 times row 2, that we change the row 3 so it becomes 0 here. And next we are going to make row 4 minus with 3 times row 2 and we change row 4. And here row 4 already become all 0, which means since row 4 consists solely of zeros, then the determinant of the matrix equal to 0. This means that the matrix is singular, equal to it's not invertible. So the matrix is not invertible, so we cannot have the inverse matrix for the K2.
Okay, for the last method, K3, so the given matrices is this. So from the K3, the task given by using inverse. So the method is same as K1 by using adjoint method. 3 times 10 minus 3 times 6 plus 1 times negative 5, we get 7 here, and times so on, and this is the result of the first column, and result of the second column will be 6, negative 24, negative 18, 15, and the third column will be 0, negative 21, negative 21 and 0, and the last column will be 2, negative 1, negative 6. So let's jump to determinant since we are finding the inverse. So determinant will be 7 times 1 minus 6 times 4 plus 0 times 4 minus 2 times 2, which equal to negative 21. So since we know to inverse matrices, we put the determinant 1 over negative 21, which we found it earlier, 21, and the number inside the new matrices will be positive, negative, and so on. Negative, positive, negative, positive, negative, positive, negative. So here are the new inverse matrices, which 7, negative 7, 0, 0, negative 6, negative 24, 18, 15, 0, 21, negative 21, 0, negative 2, 1, 6, negative 9. So this inverse with times with the given matrices. So this is the given matrices times the inverse, and we got the code here. So the new code here will decrypt into as per head start. So now we know the third matrices, K3 will decrypt the message of where Alung will be waiting us, which is at as per head start. So let's see for the K2, this is the final answer. Why this is not the final answer? Which code is A will be 0 until Z will be 25. So since we know this is the final answer, so can we decrypt the message by using these matrices? I mean negative 435 over 7, which letter will it be? And for the first K1, sorry, I mean this is the K2, this is the K1, but still the answer is wrong, right? And this is K2. The final answer will be 0, 0, 0, 0. Is that an inverse matrices? I don't think so. So this matrices has no inverse. Since that it is no inverse, so we cannot times it with the given matrices earlier. So K2 is eliminated from the choice of answer. K1 since it has and fractions and negative number, so it also eliminated from the choice given. So the final answer will be K3, which only have the logical number 0, 18, number below 25. But here we got 26, we'll just leave it empty. And the answer is as per head start. So we know the correct solve as per head start. So that's all from us. Thank you and have a nice day.